Hello everyone, I am Shreejay Jahagirdar and my teammate is Prajwal Agarwal, and our topic for CSE 564 project is a data-driven stay. That is, we'll be exploring the Airbnb data in New York City. As we know that the number of Airbnbs coming into picture increases every year. Along with that, we also know that New York City is one of the most popular tourist destinations in the world. So we decided to visualize this data set in order to assist the user, both the tenants and the homeowners, to make their final decision for the Airbnb. So we have implemented the following plots. Let's come on to the first, which is the map. It is a choropath map where different boroughs are colored according to the number of Airbnbs contained in it. And we have also provided the basic functional interaction functionalities on click, on hover, and unclick as well. So now you can see we can change the color as we hover and click, and the rest of the graphs are updated along with the tooltip indicating the region and the number of Airbnbs. Coming on to the scatter plot, which is a hybrid scatter plot and a density plot, where the y-axis represents the price and the x-axis represents the rating of that particular Airbnb. So here the size of each data point is varying due to the number of reviews. So for each data point, we have considered the number of reviews as the factor for its size. And the color for each data point is depending upon the cancellation policy, whether it is strict, moderate, or flexible. And even here also, we have bucketed each ratings, and we have provided the on-click functionalities. And as we click, the regions get highlighted and the rest of the graphs get updated. And we can see an interesting observation here that if I click on the bar of rating 1, so we can see that the count or the number of Airbnbs in Staten Island is 0. So that would be an interesting thing, since that it would mean that there is no Airbnb in particular in Staten Island, which is consistently receiving poor reviews.
So, hello everyone. So my name is Prajwal Agarwal and I'll be presenting the rest of the plots. Thank you, CJ. So first up is MDS plot, which basically shows the correlation between all the attributes that were present in our dataset, all the numerical attributes. The size of any particular attribute shows a direct correlation with the rating that any Airbnb has got. And the width of this any particular edge signifies the correlation between those two attributes. So like as you can see, the minimum nights is the one with which is the mostly related with the rating. So it shows that there must be some sort of a constraint that are placed in the higher rated Airbnbs for the minimum nights to maintain their ratings. Next up is a stack bar graph. So we have shown the construction year versus the frequency. Each bar is stacked with the room types, showing what rooms are available for the rooms that for the Airbnbs that were created in that particular year range. And these are mapped with the percentage, like how many rooms are available for that particular construction year. As you can see, one interesting observation here is like the number of hotel rooms are very less for the data set that we got, and like there are only two hotel rooms that were available, and those are available only in Manhattan. Next up is sunburst. For the sunburst, we have taken 3 levels. The first is price range. The second is instant bookable, whether the room is instant bookable or not. And the third one is uh, the cancellation policy, whether it's strict, moderate, or flexible. So, like if I do some interactions here, so let's suppose I want to check the room of only with the price range of only 300 to 600. So this scatter plot also has changed. You can see the scale has changed from 300 to 600. I also want rooms which are like in the range of 900 to 1200, but with a moderate cancellation policy, right? So like you could see that some points have been added to 900 to 600 range, and they are colored in according to the moderate cancellation policy. So these were all the graphs that we made. So for the use case purpose, like we tried solving two use cases, one from the perspective of tenants and another for the perspective of house owners. So like, let's suppose I am a tenant and I have came to New York recently. There can be two perspectives. One is I know a region that I want to live in. I know the places, and I know that I'll be staying at this particular area. Or I do not know anything. I'm a newcomer, and I just want to filter out according to the uh, room types and the ratings and make a decision accordingly whether I want to live in that region or not. So let's suppose I'm a newcomer and I want anything with anything greater than 4 rating. So I'll select 4 and 5. So for 4 and 5 rating, uh, they are mostly located in Brooklyn and Manhattan, and the list of them are present in Bronx. So I'll probably look in those areas. I'll also probably have a preference whether I want a private room or an entire home. So let's suppose I have a preference for all the private rooms, and I'd also want to like have some sort of accessibility, like whether I want to instantly book my rooms, or whether I can cancel the rooms at any later moments of time. So I can apply more filters here, and accordingly I could check whether uh, which region I could live in. I could also have gone in the different direction. I could have known which area I want to live in, and then filter accordingly according to the room type I want to live in. And this would basically help me to choose a region or choose a room type in any particular area. So next up is from the perspective of the house owners, which Shreejay would explain.
Coming on to the perspective of the homeowners, let's say I want to analyze who my competitors are and how they are doing in any particular region. Let's say I choose a region and its neighbors. So I would be looking at my competitors from that region and my neighbors as well. So let's say I want to check only those that are above 4 rating. So I will click here and check that what type of rooms do they offer, if I should offer the same or should I go for a different one. Let's suppose I am offering a new Airbnb and I have a price range in mind that I'll keep, along with some of the convenience I will provide to the users about the cancellation policy and whether it is instantly bookable or not. So I will select a particular region and see that if there are less rooms newly constructed, so people would want uh, highly rated and newly constructed rooms is something anyone would prefer. And like you can see, according to the filter, Staten Island has none of it. So that would be a very helpful insight to any homeowner to construct or to provide the Airbnbs for lodging to the users. And another interesting observation you can see, that in our data set, even though the ratings are changing, the price is not clustered at one point particular. It is distributed across the range. So regardless of the rating, whether it is very low or very high or even moderate, you can see that the price is almost evenly distributed.
And one of the other thing is, like, you could also see here, the price ranges are also equally distributed. Like for 300 to 600, there are 212 rooms, and for 600 to 900, also there's 209 rooms. So like there's sort of an even distribution, and that's another interesting observation that we got. So I guess that was it. This was all that we made. Thank you.
Thank you.